Hello class, my name is Kyle Potter and today I will be teaching you about limits. The mathematical definition for a limit is, if f of x becomes arbitrarily close to a number L as x approaches c from either side, then the limit of f of x as x approaches c is L. So in an equation that can be represented by that. So the limit of f of x, which is going to be the equation, as x approaches c, so c is going to be our x value, is equal to L. So L is our y value and as well as our limit. So for today's POD, we'll be graphing an equation. The equation we'll be graphing is f of x equals x squared plus 5x plus 6. So there's the equation right on top, along with the graph. So the points of the graph are going to be, our y-intercept is going to be 0, 6. Our x-intercepts are going to be -2, 0, and -3, 0. And three other points on the graph are going to be -1, 2, -4, 2, and -5, 6. So the reason graphing an equation will be helpful in this lesson is because one of the ways you can find limits is by graphing an equation, and to find the limit. As x approaches a number, you can use the graph to find the y value that x is approaching. The two other ways to find a limit are algebraically and using a table, numerical values. So the first example we're going to use today is finding limits using a table. So we're going to pick an equation. So that equation is going to be the limit of f of x as x approaches 2 equals x squared minus 4 over x minus 2. So we're going to create a table, and we're going to leave the x value of 2 in the table blank because we do not know what that is. So x, y. We're going to pick points that are left and points that are right of the x value to find the number that 2 is, to find the y value that 2 is going to have. So we will pick the points 1, 1.5, 1.75, 2, which we're going to put a question mark next to because we don't know the y value for it, 2.25, 2.5, and 3. So we are going to use our calculator to find these numbers. So the y value for x, the y value for as x equals 1 is going to be 3. The y value for x equals 1.5 is going to be 3.5. The y value for x equals 1.75 is going to be 3.75. The y value for x equals 2.25 is going to be 4.25. The y value for x equals 2.5 is going to be 4.5. And the y value for x equals 3 is going to be 5. So there's our table so far. As you can see, the x value 2 does not have a y value because that is the limit we are trying to find. So we're going to take the two numbers, the two x values closest to 2 on our table, which for this table it would be 1.75 and 2.25. And we are going to take their y values, and we are going to average them. So we're going to do 3.75 plus 4.25, which is going to equal 8. And then we're going to divide that by 2, which is going to equal 4. So the y value for x equals 2 is going to be 4. And there our table is full. So the limit as x approaches 2 is 4. So that is our first example on how to find limits using a table, numerical values. Our second example is going to be how to find limits using a graph. So this is the second way you can find a limit. So the equations we're going to graph are going to be x plus 3, x cannot equal 1, and then we go into 0, and x equals 1. and the limit is going to be the limit as x approaches 1. So that is our setup as of now. So we're going to graph these two equations and then find the number x's, find the y value of x equals 1. So the first point we're going to graph is we're going to do the point 1, 0, because that is very easy as it is given to us. And then we're going to graph the other equations. But x cannot equal 1, so we're going to put a circle where x would equal 1. So our first point is going to be 0, 3, which is our y-intercept, and then 1, and we're going to graph that line with a slope of 1. There's our graph. So as x approaches 1, so we have the x value 1 right here. As x approaches 1 on the graph, but see, as you see here, there's a point at 1 equals 0, but that is not the limit because the limit has to be part of a function, and this is not a function, it's just a point. So this is our function right here. So as x is approaching the x value 1, as the line is approaching x equals 1, it is going to 4. And the reason the limit is 4 is because both sides agree. So both sides are approaching 4 as x equals 1. So our limit as x approaches 1 is going to be equal to 4. There's our second example. In our third and final example, is going to be how to find limits algebraically. So this is going to involve plugging numbers into equations and solving. So the limit as x approaches 3 equals x squared minus 9 over x minus 3. So this is one of the most simple ways to find the limit, but because all you do is plug the 3 in for x. So that is what we are going to do. So 3 squared minus 9 over 3 minus 3 equals 0 over 0. Well, that is a bit of a problem because that cannot be our limit, as it is undefined with 0 in the denominator. So what we are going to have to do is we are going to have to investigate further. So the way we are going to do that, we are going to try to factor. And this works out nicely because you can factor the top. You can factor the top very easily. So x squared minus 9, so that is going to factor out into x minus 3 and x plus 3 over x minus 3, the limit x approaches 3. So once we factor it out, right here on the bottom, we're going to be able to cancel out the x minus 3's. So cancel out on the top and the bottom. So limit as x approaches 3 equals x plus 3. So that is the final equation we are going to get. So all we're going to have to do is plug 3 into x. So 3 plus 3 equals 6. So the limit as x approaches 3 is going to be 6. So as x is approaching, as the graph is approaching the x value 3, the y value is going to be 6. So those are our 3 examples. In one way, limits are very complicated. They're not used in the real world very much, but one way they are used in the real world is they are used to computer processing systems and cell phone applications use limits in their, I guess, system processors. So it helps the computer or your cell phone applications or telephone actually run. So without limits, it would be much more complicated, and those devices would not run as well as they do now. Thank you very much. This is Kyle Potter signing out, Block 3.